Create another sketch on the front plane. Run the Circle tool and check the Add Dimensions box in the Tool Properties. If this option isn't available to you, as it might not be by default, drop the tool and head to Tools, Options, Sketch, Enable on-screen numeric input on entity creation. Click OK and reactivate the Circle tool. Now the Add Dimensions property should be available to you. So you can click to begin your circle at the midpoint between the saddle and the body height, type 87 and hit Enter. Blammo! Fully constrained circle, one step. Easy. Rename the sketch Sound Hole, all one word, camel case. Because we've constrained everything to our planes, it's very easy to make adjustments to the size of the guitar simply by adjusting those planes. With simple sketches like these, it might seem silly not to just use sketch constraints instead, and that's a valid point. But I find that the planes are actually very useful and make it much easier to apply the same constraints to future features and sketches down the line. For example, if we want to add a guitar strap button to the bottom, well, we can do that by using that butt plane, and we wouldn't be able to do that if all we had used was a sketch dimension to define the butt of our guitar. Create a new sketch on the front plane and draw another line. This one from the nut down to the sound hole. And make sure to angle it slightly outward. If a dimension is automatically created for you, you may want to delete that line and disable the Add Dimensions property for the geometry tools in the future. It's useful for circles, but kind of annoying for anything else. Make sure that the top point is coincident with the nut plane, and the bottom point is coincident with the sound hole. Add a smart dimension setting the top point to 25 millimeters from the right plane. Add a point coincident to the line somewhere below the midpoint, and select that point and make it coincident with the fret 12 plane. Add a dimension so that the point is 30.5 millimeters from the right plane, exit the sketch, and title it Neck Width. You should now have a fully defined sketch. Building design intent into your models is the whole point of parametric modeling. Adding points at strategic positions along a curve can be a really useful trick to that end. In this case, I knew how wide the line needed to be at the nut and how wide it needed to be at the 12th fret. So I just used a point at the 12th fret to define the angle of my line. Create a new sketch on the front plane and draw another line from the nut down to the saddle, just inside that neck width. Make sure that the top point is coincident with the nut plane and the bottom point is coincident with the saddle. Add a smart dimension setting the top point from 20.5 millimeters from the right plane, and add a dimension so that the bottom point is 29 millimeters from the right plane. Exit that sketch and rename it E-string. Alright, just a couple more sketches before we get into something a bit more interesting. Create a new sketch on the head face plane. Draw a vertical line to represent the outside edge of the guitar head. Now try to add a dimension from the nut to one of the line's endpoints. Whoops, you can't. Why not? Well, because SOLIDWORKS Sketch Solver is strictly two-dimensional, at least within two-dimensional sketches, and can only create dimensions to planes that are perpendicular to the sketch plane. I have to admit, I get a little more than exasperated with them about this, but anyway, we can work around it. Exit the sketch and rename it Head Outline. Now run Features, Reference Geometry, Axis. Click the nut and the head face planes. We now have an axis existing at the intersection of the nut and head face planes, and while the sketcher won't be able to see that intersection by itself, it will be able to see the axis we've created. Rename the axis Head Axis and drag it above the head outline sketch, all the way back to the other head reference geometry, just so that it's easy to find and we can make use of it in our head outline sketch. Edit the head outline sketch again, and now you can add dimensions so that the bottom point is 23 millimeters from the head axis, and the top is 145 millimeters from the head axis. Dimension it to 30 millimeters from the right plane. Add a 3-point arc from the top of the neck to the base of the head. Hit Escape to drop the tool, but while the curve is still selected, Control-click the neck profile and add a tangent constraint. Add another 3-point arc from the end of the head to the symmetry plane and hit Escape to drop the tool. Make that end point of the arc coincident with the right plane, and make the midpoint of the arc coincident with the right plane as well. That will force the arc to be perfectly perpendicular with the right plane at the point of contact. Now create a vertical dimension from the midpoint to the outside edge and set it to 4 millimeters. You could obviously have used a radius value to define that curvature, but I find arc heights to be much easier to control than radius values and much less likely to cause problems during model updates. Draw a vertical centerline to represent the peg hole positions and position it at 11.5 millimeters from the outside edge of the head, 36 millimeters from the nut, and 19 millimeters vertically from the top right corner of the head. Add and dimension a 6 millimeter circle centered on top of the line. Snap a sketch point to the midpoint of the line. Another fun little quirk about the SOLIDWORKS Sketcher is this. Take a point and try to snap a sketch point to the bottom of the peg hole centerline. No can do. But there's an easy, if somewhat annoying workaround. Create your sketch point somewhere out in space, and then constrain it to be coincident with the end point of the curve. Now it works fine. Brilliant. But I'm not bitter. Continuing right along, let's define the basic angles for the side view of this bad boy. Let's create a new sketch on the right plane and draw a line approximating the neck profile, snapping to the body height and nut planes along the way. Dimension it to be 20 millimeters from the front plane at the nut, 24 millimeters from the front plane at the body height plane. Then you can exit and rename the sketch Neck Profile. Sweet.